In section 1.5, we are going to talk about segment relationships. So remember, our segment is a line with two endpoints, like this. So we're going to talk about the relationship between different segments. Our first piece, we have a relationship of equality. So in order to understand this part right here, we want to look down at this example. We have a segment AB with a midpoint x. X is in the middle. So this is like what we were talking about earlier with a midpoint. AX here is equal to XB. Those pieces of our segment are equal. That part is a review. Now this next piece, AX plus XB equals AB, that is saying if we take this segment right here, AX, and we add on this piece right here, XB, that is going to give us our whole line of AB. This whole line is equal to those two parts added together. And if you think about it, it makes sense because if we took two pieces of one segment, broke them apart into two pieces, and then put them together, it would give us our whole line again. So those concepts and those relationships are what you're going to need to remember for our examples. So if we take AX, take that piece, and put it together with XB, it's going to give us AB, the whole segment. Okay, so let's look at an example. Number 1 says that AX is 5x minus 2. So I'm going to just draw up another picture down here. AX tells me it's 5x minus 2. That's this piece of my segment right here. Then BX is 3x plus 6. Now I want to find out what x equals. Well, to do that, I know that x right here is my midpoint. It's in the middle of my segment. So that means this piece right here is going to be the same as this piece right here. Now when I go to write that as an equation, AX is equal to 5x minus 2. So I get 5x minus 2 is equal to XB, which is 3x plus 6. So now I have this equation set up where I can solve for x. So I'm going to move all my x's to the left. Five x minus 3x is 2x. Bring down my 2. I have 6 left on this side. Then I'm going to bring my number over to this side. I get 2x is equal to 8. I'll write that up here so I have more room. Divide both sides by 2. I get x is equal to 4. And that is my answer for x. Then once I have this x, I can plug it back in to figure out what ax is. So I know ax is 5x minus 2. If I plug in 4 for my x, I get 5 times 4 minus 2, which gives me 20 minus 2 is 18. That is ax. Same thing for AB. If I know that ax is 18 right here, well, if I know that this piece right here is 18, then I know that bx is also going to be 18 because they're the same. That's what these little dashes tell me on my line. They're both going to be 18. And if you want to check that, you can do that. If you plug in 4, 3 times 4 plus 6, 3 times 4 gives me 12, plus 6 is 18. So just double checking that I did my math right and I got x right. Those should be the same. Now if I want to find AB, I can take 18 plus 18 and I'm going to get the whole thing. 18 plus 18 gives me 36. Okay, let's look at the next example. So if I draw my line now, I know that this is A, B, X in the middle. AX is 4X minus 4. And this time it's giving me AB, which is my whole line. My whole line here, AB, is 6X plus 2. Well, if I know that this piece right here and this piece right here are the same, if this is 4X minus 4, then this is also 4X minus 4. So if I need to set up an equation where I can write all these things together in one, I know that my segment, AX, so if we look up above, AX plus XB equals AB. I'm going to use that. AX, which is 4X minus 4, plus XB, which is 4X minus 4, is equal to the whole line, AB, which is 6X plus 2. So once I have this equation written, all I need to do is solve. I can combine my like terms on this side. 4X plus 4X is 8X. Minus 4 is minus 8. Bring my x's to the left. Get 2x minus 8 equals 2. Add 8 to both sides to bring my 8 over. I get x equals 5. So I can fill that in, x equals 5. Now to find bx, I'm just going to plug in that 5. Bx was 4x minus 4. So when I plug in 5, 4 times 5 is 20, minus 4 is 16. And for AB this time, I could find it either by taking 16 plus 16, since I know both of those are the same, or I could plug 5 into my equation for AB. And either way, I'm going to get 32. For our last example, this relationship of equality is if we have a segment AC, but this time B is not the midpoint. B is just somewhere within our segment. So if we put it here, or if we put it somewhere else, anywhere on that segment, this relationship right here is going to be true. No matter where we put B, if we put B there, or we could put it over here, AB plus BC is always going to be the whole thing. So part plus part is always going to be the whole. Okay, so let's look at this example using that relationship. So we know that AB, we don't know where B is, but it's somewhere along this line. And if we put it here, AB is 2x minus 2. BC is x minus 3. And our whole line is x plus 7. So this example is going to be just like that last one, where we set up our equation where we have AB, 2x minus 2, plus BC, x minus 3, equals our whole line. So our part plus our part equals the whole. Then we can combine like terms. So we have 2x plus x gives us 3x. Negative 2 minus 3 is negative 5. Bring my x's to the left. And my numbers to the right. I'm going to bring that up here so we have room. Got 2 times x, so I need to divide by 2. And I get x equals 6. So then for my last part, to find AC, I'm going to plug in for that equation. AC is x plus 7. X plus 7. But my x is 6, so I have 6 plus 7 gives me 13 for my whole line.